CSIS 2470 is filmed before a live studio audience.
Hey everybody, welcome back to the next lecture in the Canvas tag section. Today we'll be talking about collision detection, which is all about seeing if objects are crossing over each other. A little bit of math involved and a whole lot of fun code. So I will turn the time over to past Jeff and present Jeff. That's me. We'll see you on the other side.
All right, let's take a look at this collision detection business with rectangles. It's a little trickier than you might think. So I got pictures here we're going to look at. Imagine this border here is our canvas. We've got some numbers in here. The proportion and the scale is totally off. Just ignore that. I mean, clearly this is not a perfect square, but yet I'm calling it a 500 by 500 square. So ignore that. I just put some numbers in there to help us kind of make a little bit of sense of this. So let's just start here. Imagine that right here in the center is a rectangle. And we're going to call it a perfect square, even though it's not square in my picture. And it's 200 pixels wide and 200 pixels high. So that's this square right here. Now, one thing that's important with this collision detection, we're going to have to remember, number one, the top left corner of our canvas is X position 0, Y position 0. As I move down the canvas, I'm still on the X0 here, but the Y position is increasing. It's at 250 and then eventually down to 500 if that's how big our canvas is. As I move across the top like so, my X position increases, but my Y position stays at 0, right? 250 is my X, 0 is my Y. 500 is my X, 0 is my Y. So it's important to understand that X gets larger as we move to the right, and Y gets larger as we move down, all right? The other thing I want to point out is when we create in our code a rectangle, we pass in 4 parameters, right? We pass in an X, a Y, a width, and a height. So when this rectangle was built, if this were actually built in our code, we would have passed in an X of 100 and a Y of 150, a height and a width of 200 each. That's what we would have passed in to build our rectangle, right? So this rectangle right here, that's called this, and you'll see why I called it that in a minute, why I called it this in a minute, is starting at position 100, 150. And then it goes still at 100 on the X right here. This number is referring to that exact point right where the crosshair is that point of the rectangle. Each of these numbers are referring to that very corner of the rectangle there, okay? By the time we get to the bottom of the rectangle, we've added 200 pixels because that's how high it is, how tall it is. So it's at position 100 for the X and 350 for the Y. And again, these proportions are wacky, but the math still works, right? And the right side here, we have the same idea going on, okay? It grew by 200 in width, and then it grew by 200 in height. That's why it's 350. So that's our starting point. Now that we have that as a basic foundation, let's take a look at interacting with another rectangle. We've added a second rectangle here. Now these numbers on the edge here are still referring just to the canvas right here. I know it's getting a little crowded right there, but that coordinate is where we are on the canvas, right? These numbers are still referring to the black rectangle right here. They're the exact same numbers we just saw on this page. It's just now we have another square that's kind of in the way, all right? I'm calling this rectangle other. I'm calling this one this, I'm calling this one other, all right? So here's what we're going to look at here. Ignore this text for just a minute. What we're looking at, if the right side of this rectangle is to the left of the left side of this rectangle, then we are not colliding. They are not intersecting each other. So there's not a collision. In other words, if the other's right here, other right, is less than this dot left. So if other dot right is less than this dot left, here's the right. Is it less than this dot left? And it is, because you can see, right, left is at 100, 150. Well, whatever right is at, we don't know exactly, but it's clearly less than that position on the x-axis. It's probably like 90 or 95 or something. This corner right here would be something like 90. So it's to the left of this. So in that case, we do not have an intersection, right? We do not have an intersection when this red text is true. All right. So let's take a look at another scenario. It's the same idea, but now the other rectangle is to the right. So again, the way we're looking at this is if whatever the left coordinate is, the other dot left is greater than the this dot right position, right? So if this left is greater than that right, then we are also not intersecting. And it doesn't matter where this blue rectangle is as far as the y-axis goes, if it's down here, up here, it doesn't matter. As long as this left side is further to the right than this right side is, we are not colliding. So again, other dot left is greater than this dot right. Now, there's something we need to consider here. What is the coordinate of the left side of this rectangle here? And by this, I do mean this rectangle right here. With the left side of it, we're looking at the x-axis. It's at 100. What's the right side going to be? Well, you can see I labeled it 300. But the truth is, it's really x, however big the rectangle is, 200. So it's whatever the x is, because the x of the rectangle will always be the top left corner. In this case, it's 100. So if I add the width of the rectangle, then I now know what the right side is. So you'll see in our code in a minute, we're not going to call these left and right. What's labeled as left here in our code is going to just be x. And what's labeled as right here is going to be x plus the width. Okay? And so the same idea is happening over here. The left side of this rectangle is just simply x. So in other words, if others x is greater than this is x plus width, then we do not have an intersection, all right? You may have to rewatch this section because it's a little tricky. So good thing we're recording, right? All right, let's take a look at the next one, the top. Similar situations happening here, right? Here's our this rectangle, same coordinates. These coordinates refer to the black rectangle, all right? Now what I'm looking for is when the bottom of the other rectangle is above the top of this rectangle. And remember, the y coordinate starts at 0 at the top and it gets larger as we go down. So that means that this bottom number, whatever it is, needs to be less than this top number right here. So the other's bottom, right here, the other's bottom has to be less than this is top, all right? And again, the top for this particular rectangle is whatever its y position is, right? The x and y of every rectangle is always its top left corner. So if I said, what's the x value of this rectangle? It would be telling me what this point is right here, this top left corner. In this case, its x is 100, but its y is 150. So the top of this rectangle is just y, or just 150. So is the bottom of this rectangle less than 150? That's the question we're asking. And obviously with the visual, it certainly is. But what exactly is the bottom of the other rectangle? Well, it's the y position of the rectangle plus the height, right? So it's y plus h, the y plus the height. So if the y plus the height, which puts us right here on the very bottom, if that number is less than whatever the y of this rectangle is, then we are not intersecting. So again, there's the equation there, all right? Last one, the bottom. Again, this is the same idea here. Again, the black rectangle is called this, and these are the coordinates for it right here. The other rectangle right here, I'm asking, is the top of the other rectangle, is it larger than the bottom of this rectangle, right? Well, what's the top of this rectangle? It's simply whatever its y position is, right? So its y position is going to be something like 360 or whatever, because this right here on the corner, this black one is 350. So I'm going to say that's about 360. I don't know. So the top is at 360. Whatever its y position is will be its top. And then we're saying, is that greater than the bottom of this rectangle? Well, what's the bottom of this rectangle? Well, it's its y, 150, plus its height, 200. So a total of 350. So is 360, which is my guess where the top is, greater than 350? If it is, we are not intersecting. So we've just looked at if any of these four positions, looking at my red highlighted text, if any one of those four positions, other dot right is less than this dot left, or other dot left is greater than this dot right, or other dot bottom is less than this dot top, or other dot top is greater than this dot bottom. If any one of those exists, only one has to exist, then we are not intersecting. So if any of those exist, we're not intersecting. If all of them don't exist, then we are intersecting, right? So if this is not true, and this is not true, and this is not true, and that is not true, then we must be intersecting. The moment these rectangles cross each other's paths, none of these red equations will be true, and we will be intersecting. All right, that's a long-winded explanation, but it's tricky stuff, so we got to make sure we understand it. So now let's dive into the code and see how this is all going to play out.
To the code.
All right, here we go. We have our JavaScript right here, and if we look, just drew these two rectangles. What I'm going to do is attach that rectangle to my mouse so that I can drag the rectangle around and bump up against that rectangle and test our collision code, all right? So here we go. First thing I want to do here is I'm going to add a variable to my thingy class. If you remember, the thingy class is what we're using to draw the rectangle. So I'm just going to add a little variable here that's called this dot a. I'm saying is standing for attached is equal to a. So we're going to add that parameter here. So now when I create a thingy, or a rectangle in this case, I'm going to pass in a true or a false value. True meaning it's going to be attached to the mouse, and false meaning it's not. So right here where I created the first rectangle, we're going to say it's false, and this one is true. So now I got these two rectangles. Now down here, I'm going to write this collide function in a minute. In the move function, I'm going to, whenever the move function is called, if this dot a is true, then I'm going to have it move wherever my mouse is, right? Well, we've already created this whole little thing here with the mouse move, all right? On the mouse move, it just stores the coordinates of the mouse. So we're going to take advantage of that down here, and we're going to just simply say that if this dot a is true, then we want this dot x to equal mouse dot x, and we want this dot y to equal mouse dot y. All right. So all that's going to do is set up anytime we move, this event will fire right here, get coordinates. This event will fire every time we move our mouse. And if we have the t move function, which is the, let's see here, t is the false one. So we want to actually do the u move function. Okay, we want to show both of them. The u move is the one that we want to move around with our mouse. So whenever I call the u move function, look what will happen here. This will call this line of code here. And if the attached variable is true, then whatever the x position of the rectangle is will be assigned to wherever my mouse is at that second. Hopefully that makes some sense. And so the other thing to keep in mind here is that this draw function, which is looping over and over again, will continuously call the move function. So this move function down here will be continuously checking to see if attached is true, which it always will be for this particular object. And so every time the move function runs, it will continuously change the x value to equal the mouse. Well, that x value for the mouse is continuously being changed because our mouse is continuously being moved. In other words, this function is being run every time I move my mouse. And this event right here, this move is being run just constantly over and over again because of our animation loop here. And so the fact that this is always changing and that this function is always moving, the rectangle will move every time I move my mouse. So let's just see if that works. And there we go. Now this rectangle is attached to my mouse, right? You'll notice, where is my mouse? It's right on the top left corner, which is the x and the y position. And I said right here, set my x to equal my mouse's x position. Well, remember the x of a rectangle and the y of the rectangle is the top left corner. All right, so now in a minute, we're going to write some collision code, and I'm going to move my rectangle right up to it. And then the moment it touches, we're going to see if my collision code fires or not, okay? So let's do that. This is our collide function here. Now, remember the way that the left and the right and the bottom and the top works. So we're going to make some little notes here. And remember that the top of any given rectangle is just simply equal to its x position, right? And the left of any given rectangle is just equal to its, sorry, I did that backwards. That's the y. All right, and the left is equal to its x position, right? Okay, well, what's the bottom? The bottom is equal to the y plus the height, not the handler event. And then what is the right? It's equal to the x plus the width. Hopefully that makes sense based on that long-winded explanation I gave over here, showing how all this stuff works, right? All right, so again, just a real simple look at this. This is the xy, 100, 150. And I said, what's the top? Well, the top is just 150y. It's just the y coordinate. What's the bottom? Well, it's the y coordinate plus 200 more for the height, which gives me 350, which is why the bottom is y plus height. All right, easy enough. Now let's take a look at this. I'm passing in an object, which is just going to be another thingy. So ultimately what's going to happen up here is in my draw loop, I'm going to ask the question basically, if u dot collide, let's go with collides, that's a better name. If u collides with t, right? That's the question I'm going to ask. I'm going to say, if this collides, then console.log it, right? That's what we're going to say. So I need this function down here to return true or false. Well, keep in mind what's happening. U is one of the squares. It's the one that happens to be attached to the mouse. and t is the other square. So u is this. What's this? This is always the object that's calling the function, right? So at the moment when I am about to run the collides function, which version of it am I running? Because I've got a t and I've got a u object. Which one am I running? Well, I'm running the u's version. And so that's what this is. This refers to the object that's calling the method. Well, what's this other business here? T. Well, that's the other one, right? So that's why I called it other. So we're calling this function, we're passing it in this as an argument to be captured by that parameter. That's the other one, all right? So we want to say something like this. Remember our formulas. We got them all in that spreadsheet over here, right? So I want to know if other.right is less than this.left. Well, let's just copy that right here. Let's see if I can copy it right out of there. And we'll have to modify it a little bit. Okay, if other.right, well, there is no right property, right? What is right? Well, it's x plus y. So if others x, plus width I meant, plus others is less than this dot left. Well, what is left? Left is just simply x. So this dot x. So that's one of the conditions right there, all right? And I got a feeling that this is going to get really long. So I'm going to change this variable to just be called O for other. So that way we have a lot more room. So if this condition is true, or let's look at our next one here. I can just copy and paste it. This one right here is true. So again, we're going to change that to an O. And then what's left? Well, we know left is actually just x. So if others x is greater than this is right. Well, what's right? It's x plus w. So this dot x plus this dot w. Okay? And let's look at the next one. If that's true, or this is true, or this is true, right here, let's copy that one. And again, we're going to change that to O. So what's bottom? So if others bottom, that's y plus h. So others y plus others h is less than this is top. Well, what is a top? A top is just y, as we can see right there, okay? All right, so if any of those three are true, or last but not least, if this is true right here, all right? Let's copy that. And we're going to call that other again, just O, I should say. So if O dot top, well, what's top? Because there is no such thing as a top. We didn't create a variable called top. It's y. So we're saying, in other words, y. All right, is greater than this dot bottom. Well, we don't have a bottom, but we do have a y and an h. So y plus this dot h. So if any of those things are true, then we are not colliding. So I can return false if any of those are true. Else, return true. That's it. That's the whole algorithm right there. Assuming I didn't screw anything up, which you never know with me, right? So again, we're going to ask the question, if U is colliding with, and maybe a better name for that would be is colliding instead of collides, but whatever. If U collides with T, then console.log hit. Now, when we first run it, if I did my code correctly, it's going to log a bunch of hits right away, because before I actually move my mouse, the rectangles will be on top of each other. So we'll see that happen, assuming I didn't screw anything up. Let me open up the console here and get this out right here. All right, so now I'm going to refresh the page, and look, it's logging a bunch of hits, right? Because my rectangle's on top. So let's clear that. And so here we go. I'm going to move my rectangle from the right side here, and we'll go right up against the edge there. And so far, nothing. Hopefully right when I get there,